Today we're building our most powerful Vortec 4200 that we've ever done. That means forged pistons, forged rods, and we're not stopping until we go faster than an 862. That's right, we're going to start stepping up our game with the 4200. Now, if you guys are just tuning into the channel, we've been developing these engines for about 3 years now, and we have basically been pushing the stock bottom end as hard as we can. Oh, this thing is with a stock bottom end, the most amount of horsepower that we were able to get was 824 wheel horsepower. Then we built a twin turbo little red Datsun, and we installed forged connecting rods into that engine. We made 867 horsepower with that, and we had finally broken the 1,000 crankshaft horsepower mark. Unfortunately, with that deal, we noticed that the pistons were really starting to wear out, and we were seeing a lot of oil out of the exhaust just because the pistons were no longer sealing as well. It still made power, but we knew there was a problem. We discussed this issue with a few guys at PRI, and we basically came to the conclusion that we are overpowering the stock piston. So the goal with this motor is I want to build this motor to go into my Fairmont station wagon. And the whole reason that I built that car was it was sort of a hybrid between the Mighty Car Mods Toyota Cresta, which has a Barra power plant, and the 66 Chevy Nova that participated at the very first drag week and sported a Vortec 4200 built by the guys at Self Racing Engines. The quickest that that car was ever able to do at drag week was an 862 in the quarter mile. And that is the time to beat. So using everything that we have learned, what we have come down to is we need a set of forged pistons. Unfortunately, our units from Mali are not ready yet, so I'm going to have to return to my original plan, which was these Wiseco Subaru pistons. And today we are going to show you how we plan to fit these up to the Vortec 4200 and basically assemble this beast. When I originally started searching for pistons for this engine, I wanted something that was an off-the-shelf offering. What I landed on was a Subaru EJ20 stroker piston. Specifically, it is a 93 millimeter bore, and I'm not sure what it strokes out to, but the important part is the pin height on the piston is 1.181 inches. And the other important part is that the pin size is 0.905 inches, which matches the Vortec 4200. Now, the compression height or pin height is not quite the dimension that we need it to be, but these are dished pistons, and therefore we can shave a little bit off the top, and we're not like thinning out the top of the piston and causing any issues there. Basically, we are going to chuck the piston up in this thing and then use the cutting tool here to cut a little bit off of the piston. And to do that, I made this tool here, which is basically a steel rod that I machined down to 0.905 inches, and that slips into the pin boss. Something else to keep in mind is you don't want to put force on your skirts because they will bend very easily. So we're going to be putting some aluminum spacers in, and then when we clamp down the bolt, it will put the force onto the strongest part of the piston and we won't bend the thing. Yep, that's not going anywhere. Next, we're going to take a dial indicator and we are going to get an idea on how square this is. Yeah, it's pretty far out. Alright guys, the next thing that we need to do is we need to gap the rings. Wiseco sent along this nice little chart which basically details how much you should gap the rings based on the particular application that you plan to use it for. We plan to run high boost and 30 plus pounds of boost, so it recommends 0.008 per inch of bore. So we have a 3.661 inch bore, so 3.661 times 0.008 gives us 0.029 or 29 thousandths, and I'm just going to round that up to 30 thousandths. So let's get these things gapped up and we can move on to the next step. It is a nice cool 4 degrees outside, and this Christmas I am very thankful to have a heated garage. In this heated garage we got this fancy tool right here, which is a Bridgeport milling machine, and I'm going to use that to modify our connecting rods. Now some of you might be saying, you've already modified your pistons, now you're modifying your connecting rods? Well, this mod is a little less in depth, but one of our takeaways from our trip to PRI is we noticed that a lot of connecting rods had a cylinder wall oiling divot in the side of the connecting rod. Now, if you're familiar with the Vortec 4200, you'll know that they added an oiler to the later engines. You can see right here, there is a little hole in the connecting rod and there is a hole in the bearing. And basically that squirts oil up onto the cylinder wall and helps keep the piston cool and the piston lubricated. What we didn't realize is the early rods also have an oiler, and it is in the form of this little slot here on the side of the connecting rod. GM thought it was a good idea, so we are actually going to add that to our aftermarket rod. And to do that, I made a tool that I 3D printed. And basically how this works is it is essentially like a work stop, and you use it to line up on the rod like so. And then you can use this face here to push up against the vise, and it will help locate the rod in the same spot every time. And then you will machine the front face and the back face, and then you will turn the rod around and then machine the front face and back face again, and you will have a rod that is ready to go. Next up, we need to install the rods and pistons. So let's get to work.
Calvin, there you are.
Hello.
I made your cheesecake. It's in the oven.
Oh boy.
I hope it's good. This is for your car.
Yeah.
Number one.
Number one.
Are the others in? This is the first one.
This is the first one. Okay, here we go.
Okay, push it down in.
There it goes.
There it goes. Yay!
There you go.
Number one is done. You got me all greasy.
Grease it.
Flip it.
Grease it. Hello.
Put the screws in.
You line up the tang. See the tang?
Tang. Where's the tang?
Not the
Is
soda.
that the tang?
Mhm.
Orange tang. Okay.
Push.
Line it up. I don't know, I changed it a little bit. Maybe I shouldn't. Once you get on it. Did you try itching yourself? There's all kind of crud on your forehead. Do 30, 60, 90.
Beep.
Beep.
Now that we have our first piston installed, we're going to check our piston to deck distance. And to do that, I have this little tool here. And we come up with 21.5 thousandths. So the head gaskets on these motors, at least the one that I have, is a 19 thousandths head gasket. So we take the 21.5 plus 19, and that gives us 40.5. I was shooting for 40 thousandths between the piston and the cylinder head, just to be on the safe side. I know some people make them a little tighter, but this will still give me 9.2 to 1 compression. So I'm hoping that that will not be too sluggish. So just wanted to double check that I actually machined the piston right. Alright guys, we now have all the rods and pistons installed into the engine and all torqued up. So next we are going to start looking towards putting the cylinder head on. But before we do that, we got to get the front cover removed, because in order to time the engine, we need to have a look at the crankshaft sprocket and make sure that the chain is lined up correctly on the dot and get that all situated. Also, we need to reset the tensioner so that we can even get the chain up and around the camshafts. So next we're going to remove the front cover. Piece of cake. Here it goes. Calm down. There you go. Hey. Some of you may have been starting to wonder whether this thing actually existed or not, but this is the Faster Proms ported head. And this is actually the very last head that was ported by LS George. This thing has been ported within an inch of its life, and I must say it is pretty much artwork on the ports. I'm super thrilled with how it came out. We had a valve job done on it since then by our friends at Snyder Performance, and it is pretty much ready to go onto the engine. So let's get it on there. Alright guys, I was about to flop the cylinder head on, and I wanted to just mention one more thing. Make sure that you are careful with your head gasket. The little rivets that hold the multi-layer steel. There have been instances of some defects with some manufacturers where they put the rivet in a spot where it could be pinched between the block and the head, and it won't let the head sit down flat. So just double check that all the rivets are in the correct spots and they won't get crushed and keep you from sealing your head gasket. We need to install our Schneider Racing reground cams, along with one of our Niblack 57 cam installation kits. I've actually already done that, so we just need to drop the cams in and we'll be good to go. is we are going to time the engine. So in order to do that, we need to get the engine on pretty close to top dead center. And then we need to feed the timing chain up through the engine, like so. Alright, the timing chains on a Vortec 4200, every 7 links there is a different colored link. Basically you need to get the different colored link onto the timing mark on the crankshaft, and then you're going to line up the different colored link up on the camshafts, and that is how you time the motor. Some of the tricky things with this is you need to reset the timing chain tensioner, which isn't too hard. Basically, it's a ratcheting style mechanism, and you basically pull this little lever here, and then it allows you to push the tensioner back in. There's one other thing to note here, and that is that we like to advance the camshaft on the exhaust side 1 tooth in order to keep the valves away from the pistons when the camshaft is at maximum retard with the VVT. Guys, some of you might be wondering, how much did this all cost? Well, let's break it down for you. We bought a 2004 engine. It was right around 200 bucks. The Molnar forged connecting rods were right around 700 bucks. The Wiseco forged pistons were right around 800 bucks. The Faster Proms ported cylinder head, that was about 1,000 bucks to get that all done, you know, including the valve job and everything. We installed some Crower valve springs. Those are about 120 bucks. We installed one of our cam installation kits, which we sell for 200 bucks. Some Schneider Racing reground cams, which is about 400 bucks. So all in all, I'll put the total up here. I can't do it in my head at the moment, but you know, it's a heck of a lot cheaper than if you were to import, say, a Barra. So with that, I want to wish everybody out there a Merry Christmas and a Happy New Year. Safe travels and all that. Make sure that you like, comment, and subscribe. Take a guess at how much power you think we're going to make with this motor. Maybe consider hitting the join button down below, buy a t-shirt, and we'll see you in the next one.